So in case I give a vessel hard over to starboard, which side would my vessel heel over? Any ideas?
Starboard side.
Port side.
So she will heel over opposite side from the turn. That means अगर मैं starboard देता हूँ, she will heel away from the center of turn. She will heel. This is under normal circumstance. That means this is for our vessel, merchant vessel. The ship on which we all go. And the condition for this is basically the kg is going to be greater than the kb. That means my vessel kg will always be more than kb. Your vessel, same story. So she will heel away. अब क्वेश्चन है कि क्यों ऐसा होता है? So basically, when a body moves, this is the radius of the turn. When a body moves along a circular path, so let me just read it out from the book to you. It's available to you in Hinship. I am on page 230 of Hinship. So it says that when a body moves in a circular path, it experiences will be a centripetal force, which will take it towards the center of the turn. So that centripetal force will be mv square by r, and that will be the centripetal force. So centripetal force acts inward. Centripetal force. Equal and opposite, there is going to be a centrifugal force, which will be taking it away from the center of the turn. Okay, so but अब ये सेंट्रीफ्यूगल फोर्स कहां पे एक्ट कर रहा है और किस पॉइंट के थ्रू एक्ट कर रहा है? The centrifugal force is acting through the COG of the vessel, the center of gravity of the vessel, outwardly. मतलब इसका जो लीवर बन रहा है सेंट्रीफ्यूगल फोर्स, is acting of lateral resistance of the ship. अब ये सेंटर ऑफ लेटरल रेजिस्टेंस क्या है?
सर थोड़ी वीडियो रुक के आउंदी सर थोड़ी।
अगर ये मेरा जहाज है, मैं हाँ जी क्या बोल रहे हो? थोड़ी वीडियो विच रुकी जाती है सर। अच्छा, इज इट फॉर एवरीबॉडी?
यस सर।
Yes, sir.
यस सर।
ओके, अब यहाँ पे ये थोड़े से चैलेंजेस आएंगे एट साकेत बिकॉज इंटरनेट कनेक्टिविटी व्हाटएवर, So I'll sort this out. So I will repeat whatever you are not able to understand. I'll repeat that for today, tomorrow, so that till we sort out this. So just let me know and then I'll repeat the sentence. So what I'm saying is basically that this vessel, if I give hard starboard to it, ऐसे जाएगा, ऐसे. तो ये जो साइड है, इसकी स्टार्बर्ड साइड, यहाँ पे अंडर वाटर ड्राफ्ट है एंड यहाँ पे देर इज अ लेटरल रेजिस्टेंस which is offered by the water. So the centripetal force will be acting at the center of this lateral resistance. अब ये lateral resistance क्या है? ये approximately centroid of the projected underwater lateral area है. Centroid of the projected underwater lateral area. और ये सेंट्रॉइड ऑफ द प्रोजेक्टेड अंडरवाटर लेटरल एरिया क्या है? ये रफली इक्वल टू केबी है, सेंटर ऑफ बॉयंसी. एंड ये केबी क्या है? अप्रोक्सीमेटली हाफ द ड्राफ्ट. तो कहने का मतलब मोटा मोटा ये है कि सेंट्रीपिटल फोर्स केबी के थ्रू एक्ट कर रहा है, तो जो मोमेंट बन रहा है वो सेंट्रीपिटल फोर्स मल्टीप्लाइड बाय केबी है. एंड सेंट्रीफ्यूगल फोर्स का जो मोमेंट है वो सेंट्रीफ्यूगल फोर्स मल्टीप्लाइड बाय केजी है. सो द मोमेंट टू द पॉट is centrifugal force into kg, the lever, and the moment to starboard is centripetal force into kb, which is the lever. So mota mota, the moment to port is greater than moment to starboard. Do you agree to this statement of mine? Is this okay with everyone?
Yes, sir.
Moment to port is going to be greater than moment to starboard. And because the moment to port is going to be greater than moment to starboard, therefore the heel will be to the port. Or in other words, away from center of turn. Is this okay with everyone?
सर ये सेंट्रीपिटल फोर्स वाला रिपीट करना है.
कौन सा वाला पार्ट?
सीपी वाला सर.
नहीं, I can't hear you.
सीपी वाला सेंट्रीपिटल फोर्स.
Centripetal force.
Centripetal force. Okay. Centripetal force is acting through the center of the lateral resistance on the starboard side. तो जो भी lateral resistance है, नीचे का पोर्शन जो पानी के नीचे है, उसका जो सेंटर है, ये सेंट्रीपिटल फोर्स उसके थ्रू एक्ट करेगा इनवर्ड. एंड that height of that center is going to be almost equal to the centroid of the projected underwater lateral area, and the height of that will be equal to kb, and the height of that will be equal to half the draft. ये कहने का मतलब है. मतलब अगर मैं इसको और थोड़ा सिंप्लीफाई करके दिखाऊं तो मोटा मोटा कुछ ऐसी बातें कर रहा हूं मैं. ये मेरा लेटरल रेजिस्टेंस एरिया है। इसका जो सेंटर है वो कुछ यहां पे होगा, और ये जो होगा ये केबी की हाइट पे होगा। तो therefore the lever, one can say that the centripetal force is acting through kb, and kb is nothing but half the draft approximately. So in other words, centripetal force is acting through half the draft or kb. On the other hand, the g might be somewhere here on top. The centrifugal force is going to be acting through the center of gravity. And quite obviously, the moment to port is going to be greater than the moment to starboard. And therefore, the issue. Is it making some sense now?
Yes, sir.
Is it okay?
Yes, sir.
Ab, any questions before I move to the formula now? I'm moving to the formula. The formula is tan theta is equal to V square into kg difference d by 2 for angle of heel. This is the formula for angle of heel. G is acceleration due to gravity, 9.81 meters per second square. R is radius of turn. GM fluid, you know. V is velocity of turn in meters per second. V is the velocity numerical. I am doing question number 118 from Hinge. It says a ship with km 7.2 meters, kg 6.8 meters, kb circle of radius 420 meter, speed 13 knots. Calculate the heel produced. Calculate the heel produced. सारी वैल्यूज आपको दी हुई हैं, आपको खाली यूनिट्स को put the formula tan theta is equal to v square, velocity of turn in meters per second, 13 knot into meters per second, 1852.3 divided by 3600 v square whole square, v square पूरा का पूरा स्क्वायर हो गया into kg 6.8 माइनस d by 2 ड्राफ्ट नहीं दिया हुआ लेकिन kb दिया हुआ है, सो kb इज इक्वल टू d by 2 upon g 9.81, रेडियस ऑफ टर्न 420 into gm fluid km minus kg 0.4. अगर FSC ये दिया होता तो माइनस FSC भी होता, अगर FSM दिया होता तो FSC निकालता, FSM डिवाइडेड बाय W, फिर मुझे W दिया होता. इज दैट ओके? How much are you getting?
सर 0.4 कैसे आया सर?
जीरो पॉइंट फोर कैसे आया? 0.4 कैसे आया? सो मेरे को चाहिए GM. तो GM इज व्हाट? KM minus KG.
Okay, sir. Copy.
Got it?
Yes, sir.
Is that okay?
Yes, sir. Okay.
Yes, sir. 0.67.
4.5.
4.5.
4.5.
4 point. Away from the center. So you'll write down away. So same story basically. Supposing case number 2. ये case number 1 था. Case number 2. When kg is less than kb. This question is over. Okay, this question is over. But supposing in another question, I give you kb is 6.8 and kg is 3.9. your theta will be same, 4.5 degrees. Where will you heel?
Towards
the center.
Correct. Absolutely right. Towards the center. Which are these ships? These are essentially naval ships, submarines. These are essentially submarines. So what happens in the case of submarine is basically when a submarine is floating in the water, so she's got a ballast tanks on the sides. Okay. That's what a submarine has got. So her G is on top and her B is down below. So she is behaving like a merchant ship. Now she wants to go underwater. So she'll start filling the water in the ballast tanks. When she starts filling the water in the ballast tanks, she will become like this. What will happen? Her G and B will coincide and she'll be submerged like this. She further takes more water. She goes underwater. Her B remains the same, but her G goes down. G goes below the B. Now in this position, it is our case number 2. You get it? So a submarine in a submerged position, when she gives hard starboard, she will heel to the starboard. But a submarine in a non-submerged position, when on surface, she'll behave like a merchant ship. Do you get it? Are you with me?
yes, sir. Understood.
Yes, sir.
क्लियर है बिल्कुल, कोई डाउट नहीं है. ये हील ड्यूरिंग टर्न का कॉन्सेप्ट न्यूमेरिकल में छोटा सा न्यूमेरिकल है लेकिन कभी कभी आ जाता है, तो लड्डू है. नाउ आई वांट यू टू प्रैक्टिस फॉर होमवर्क क्वेश्चन नंबर 119 and 120. Please practice these two questions, 119 and 120 for your homework. Will you do that?